Proteins. Let's zoom in on them. Proteins are made up of polymers known as polypeptides. The monomers for those polypeptides are known as amino acids, seen here. The amino group makes up the N-terminus, and the carboxyl group makes up the C-terminus. If you ever forget the name, just remember the amino group and the organic acid group. There's an H and an R side chain. The R side chain is what differentiates the 20 different types of amino acids. But how do we get from these amino acids to a polypeptide? Well, through a ribosome, which is shown in purple. In a process known as translation, transcribed and processed mRNA, which is in blue, moves through the ribosome, adding the amino acid to the polypeptide chain with a peptide bond and releasing the amino acid-less tRNA at the end. It is started when the AUG on the mRNA is detected, and it is ended when a stop codon is detected on the mRNA, as shown in the image. The polypeptide is then set free. Now, the polypeptide needs to be folded. The polypeptide straight out of translation is the protein's primary structure, like beads on a string. The secondary structure is formed by local hydrogen bonding. It can either form an alpha helix or a beta pleated sheet. The trietary structure folds upon the secondary structure and is more secure, supported by ionic bonds, hydrophobic interactions, and disulfide bridges. Sometimes multiple polypeptides are aggregated together to form a quaternary structure as seen here. Proteins have lots of functions like mobility, communication, enzymes, storage, and structure. Proteins can denature with a change in temperature, pH, or salinity, as the folding of the protein degrades due to the interactions that make them up degrading. And that's a little about the coolest macromolecule, proteins.